Hi, we are here to tell you about a sensor technology that detects the presence of harmful volatile organic compounds in plastic odors. The production of plastic worldwide is multiplying each year due to its increasing demand, such as, in 2014, the production of plastic was 4% higher than the previous year's production. Also, the feasibility of plastic has already displaced materials like wood, glass and metal. But is plastic safe? Plastic has its odor and contains harmful volatile organic compounds that carries a strong potential of posing serious health risk if contacted for a long term. Many VOCs are known to cause cancer and can severely affect the immune system, kidneys, and other vital organs. Immediate symptoms of VOC exposure can include respiratory problems, nausea, headaches, fatigue, and dizziness. But don't worry much. California-based EST Incorporated substantial electronic nose called Z-Nose offers a medium which can assure the safety of using plastic by detecting the presence of VOCs in plastic odor within a minute. So here is the process by which Z-Nose quantifies the chemistry of plastic odor. Initially, the plastic odor is sampled and its organic vapor are collected on the trap. Then, the trap is switched into the helium section, where the collected organic compounds were injected into the helium gas. The organic compounds pass through a capillary column with different velocities, and thus individual chemicals exit the column at characteristic times. As they exit the column, they are detected and quantified by a solid-state detector. Now let's take a look at sampling vapors from plastics at room temperature. Primarily, the 4 plastic rods were separated into 2 groups, Sample 1 and Sample 2 of 2 rods each. The Sample 2 produced a distinctive and unpleasant odor, while Sample 1 produced only a very slight odor. Odors from each of the 4 rods were measured by sampling vial headspace vapors. Sampling removed approximately 10 milliliters air from the 40 milliliter vial. Here are the results of sampling vapors from plastics at room temperature. Sample 1 produced only 4 distinct chemicals, while Sample 2 produced 8, at much higher concentration measured in peak area. Now, let's take a look at testing sample vapors at higher temperature. A vial heater was used to maintain a vial temperature of 60 degrees Celsius. Sample vial temperature was maintained for 10 minutes prior to sampling headspace vapors with the Z-Nose. Here are the results of testing sample vapors at higher temperature. Sample 1 produced only 6 distinct chemicals, while Sample 2 produced 9, at much higher concentration measured in peak area. The presence of additional chemicals in Sample 2 were responsible for the distinctive odor of Sample 2 plastics. Hence, EST Incorporated Z-Nose is a good option to be used as a quality controlling tool, as it identifies odors and fragrances based upon their full chemical signature, unlike trace detectors, which only detect a few select compounds. Therefore, Z-Nose has an immense capability of satiating nearly all the requirements of detecting hazardous volatile organic compounds from the odor of plastics, offering a safe and healthy product to the consumers for usage.
Electronic Sensor Technology has developed and patented a breakthrough electronic nose technology, trademarked Z-Nose, which complements existing security systems and eliminates the vulnerabilities associated with current trace and X-ray detection systems. For more information, please visit our website www.estcal.com. In case you would like to know more about Electronic Sensor Technology's flagship product, Z-Nose, please send us an email to italib@estcal.com or call us on 805-214-6096.